Welcome back to section 9.3.1. We're going to be talking today about using synthetic division to help us solve polynomials. Now, the first thing we have is what's called the remainder theorem. Now, the remainder theorem says if a polynomial is divided by x minus k, the factor of x minus k, which means that k is the number on the outside. The remainder of that is the value of the function when evaluated at k. So what happens is if you put k in the end, the remainder here, the last number, so when you find f of k, the value of that function is r. And that's a way we can use, and that's called synthetic substitution. We'll talk about that a little bit more later on. Now, the factor theorem, and this is really the important part for today. The factor theorem says if you're dividing by a factor, if it already has a factor of x minus k, that's only going to be the case if f of x equals 0. So what happens is when you do your synthetic division, where k is on the outside, if our remainder is 0, that means x minus k is a factor. And we're going to be seeing that a lot. So if that doesn't make sense now, it'll make sense later on. So what we want to do is if you want to find the exact roots of the function, x cubed plus 2x squared minus 7x minus 2, there's no other way for us to solve this really. What we can do is we can look at our calculator. So take a moment and graph this. So pause, graph it, and then when you do that, you'll see x equals 2. We have an x-intercept at 2, 0. Now, the factor that goes with that, you always subtract your zeros from x. So it would be x minus 2. Now, we can use synthetic division to determine the other factor. So to do that, what we're going to do, x equals 2. So 2 goes on the outside, and on the inside go our coefficients. 1 for x cubed, 2 for x squared, negative 7 for x, and negative 2 for our constant. So bring down the 1. 2 times 1 is 2. When we add, we get a 4. 2 times 4 is 8. When you add, you get a 1. 2 times 1 is 2. So when we add, you get a 0. That's our factor theorem. The remainder is 0, so x minus 2 was our factor. So what that's telling us is that our function, f of x, equals our first factor, x minus 2. That's what we divided by. And here, since this was x cubed at the bottom, it's x squared, x constant, and the remainder of 0. So our other factor, x squared plus 4x plus 1. Now we can find the other zeros. Now, looking at this, I'm going to check b squared minus 4ac. I want to check to see if this quadratic is factorable. Because once we get down to the quadratic, we either factor it or we can't. So it's 4 squared minus 4 times 1 times 1. That's 16 minus 4, which is 12, which is not a perfect square. It's not factorable. So we're going to find the zeros. So set x minus 2 equals 0. We already know that one. X equals 2. We had that. X squared plus 4x plus 1 equals 0. What we can do is we can solve that. It's not factorable, so we could either complete the square or use the quadratic formula. This is actually a decent one for complete the square, but I think most people use the quadratic formula at this point. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So the opposite of b, it's going to be negative 4 plus or minus the square root of b squared. So it's going to be 4 squared minus 4 times 1 times 1, all divided by 2 times 1. Now, we already found that, so we actually didn't have to do the discriminant under there. Negative 4 plus or minus the square root of 12, all divided by 2. The square root of 12, when we simplify it, it's the square root of 4 times the square root of 3, so it's 2 square root of 3. So x equals negative 4 plus or minus 2 square root of 3 all divided by 2. So it's going to be negative 4 over 2 plus or minus 2 square root of 3 over 2. Negative 2 plus or minus the square root of 3. There's our zeros. There's our 3 zeros. So our zero is x equals 2, x equals 2 minus the square root of 3, and x equals 2 plus the square root of 3. There's our 3 zeros. And you'll see on your graph you have 3 x-intercepts. And that's where the 3 zeros are. Let's go to some more examples of this. Now we're going to factor this given that one of our solutions is x equals 1. So now our factor that goes with x equals 1 is x minus 1. You always subtract the 0 from x. But when we do our synthetic division, the 1 does go on the outside, the positive. And our coefficients for x cubed, it's 2. And then we have the x squared is 3. For the x, it's a negative 8. And then the 3 for our constant. Bring down the 2. 1 times 2 is 2. So when we add, we get a 5. 1 times 5 is 5. So when we add, we get a negative 3. 1 times negative 3 is negative 3. So our remainder is 0. From that remainder theorem, that factor theorem, x minus 1 was a factor. X equals 1 is a solution. So what we get, if we're factoring this, x minus 1 is one of our factors. And now at the bottom, it goes down by degree, x squared, x constant remainder. So our other factor is 2x squared plus 5x minus 3. And once we get down to a quadratic, it's either factorable or it is not. This quadratic, if I check the discriminant, b squared minus 4ac. So it's going to be 5 squared minus 4 times 2 times negative 3. So it's 25 minus 24, which is 1. It's a perfect square. It's factorable. Now, if you need to do the diamond and box still, go ahead. So you multiply the top two numbers, the first and last numbers, you get a 6x squared, negative 6x squared. Middle number is a 5x. Now the numbers that multiply to negative 6 and add to 5 are a positive 6x and a negative 1x. So if we factor by grouping, our original first term, 2x squared, 6x, negative x, and the last number in the original is negative 3. So our common factor of the first two is 2x. So that's going to be times x plus 3. Factor out a negative 1, and then you have x plus 3. So our common factor, x plus 3, and then what's left over, 2x minus 1. There it is. We factored. Now, that's factored. So the solutions set each factor equals 0. X minus 1 equals 0. X plus 3 equals 0. 2x minus 1 equals 0. So our solutions, x equals 1, x equals negative 3, and x equals 1/2. And if you were to graph that polynomial, you'll see that that's where your 3 x-intercepts are. Let's do another one. Now they're giving us the factor x minus 5. So set x minus 5 equal to 0, x equals 5. That's what goes on the outside in our synthetic division. So on the inside, 1, negative 9, 19, and 5. So now we bring down the 1. 5 times 1 is 5. Add, you get a negative 4. Multiply, you get a negative 20. Add, you get a negative 1, negative 5. And our remainder is 0. By the factor theorem, we found a good factor. So our factors, x minus 5, that was given to us. And here, this was our x cubed, so x squared minus 4x minus 1 equals 0. Looking at our discriminant, just to see if it's factorable, b squared minus 4ac, negative 4 squared minus 4 times 1, that's 16 minus 4, which is 12. It's not a perfect square. It's not factorable. So that's fully factored. So to solve, set the factors equal to 0. So x equals 5, we already knew that. And now x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So x equals, now the opposite of b. The opposite of negative 4 is 4 plus or minus. Now we already found b squared minus 4ac, it's 12. So the square root of 12 over 2. The square root of 12 is the square root of 4 times the square root of 3. So it's 2 square root of 3. So that equals 4 plus or minus 2 square root of 3, all divided by 2. So split them up. 4 divided by 2 plus or minus 2 square root of 3 over 2. So x equals 2 plus or minus the square root of 3. So our zeros, 2 plus or minus the square root of 3, and x equals 5. There's our 3 zeros. Good. Now, what we can do in number 9 is we're going to multiply the polynomials. That's how we can take these from factored form and write them into standard form. So to multiply 3 or more numbers, you pick 2 and multiply those first. I'm going to multiply the x plus 3 and the x minus 5. So that leaves me x minus 2 times, so when I multiply, I get x squared minus 5x plus 3x minus 15. X minus 2 times, and now we combine our like terms, x squared minus 2x minus 15. And now we multiply the binomial and trinomial. Distribute the x, we get x cubed minus 2x squared minus 15x. Distribute the negative 2x squared plus 4x plus 30. So when I combine, x cubed minus 4x squared Hold on, I made a mistake, I think. No, I think we're good. Minus 4x squared, give me a second. Minus 11x. And then plus 30. And that's what we get in standard form. We can do the same thing here. Now when you square the x minus 3, so I'm going to have x squared. Now x minus 3 squared. X minus 3 times x minus 3. Just to save myself a little bit of room, it's x squared minus 3x minus 3x plus 9, which is x squared minus 6x plus 9 times x plus 4. Now I'm going to distribute the x squared, so I get x to the 4th minus 6x cubed plus 9x squared. And that's going to be multiplied by x plus 4. So I'm going to distribute the x. So I get x to the 5th minus 6x to the 4th plus 9x cubed. And I distribute the 4. So I get plus 4x to the 4th minus 24x cubed plus 36x squared. Now I combine. I get x to the 5th minus 2x to the 4th minus 15x cubed, and then I get plus 36x squared. And there's our polynomial in standard form. So to get into standard form, from factored form, you just simplify, you multiply. Now, looking at problem number 10 to finish up. Find the factors of 5x squared minus 7x minus 6. So now, they're telling us to find the factor, so we're kind of given that it's factorable. So we multiply the first and last, we get a negative 30x squared and a negative 7x. To multiply to negative 30 and add to negative 6. Now, oh, sorry, add to negative 7, are factors of 30. 3 and 10, and actually we found it right away. So we're going to have a negative 10x and a positive 3x. So if we factor by grouping, 5x squared, our original first term, the negative 6, our original last term, and then these two numbers go in the middle. Negative 10x plus 3x. Grouping, for common factor of the first two terms, we get 5x, and that's going to be x minus 2. Last two terms, a positive 3, and then x minus 2. So our common factor, x minus 2, and then 5x plus 3. So there's our factors. Now our solution, set the factors equal to 0. X minus 2 equals 0. 5x plus 3 equals 0. So x equals 2, and x equals negative 3/5. Now, how are the solutions related to the leading coefficient and the constant? Now, the leading coefficient is a 5, and the constant is a negative 6. Now, the factors of the constant, if I put those up top, the factors of negative 6 could be a positive or negative 1 and a positive or negative 6. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now that gives me all of them, because I could have a 1 and a negative 6, negative 1 and a positive 6, negative 2 and a positive 3, positive 2 and a negative 3. So those are the factors. You want to put those plus or minuses there. And my leading coefficient is 1. So that's just 1 times 5. So it could be a positive 1 and a negative 5, or a negative 1 and a positive 5. Now, if I divide these, if I divide them all by 1, 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 6 divided by 1 is 6. And now when I divide those by 5, I get plus or minus 1/5, plus or minus 2/5, plus or minus 3/5, plus or minus 6/5. Negative 3/5 was one of our solutions, and so was 2. Those factors are related to our possible solutions, and we'll be talking about that in the next section. Thank you, and I'll see you in the next one.